Hello, here I discuss the relevant features of the developed software. Here, the developed software is capable to solve all the short circuit problem in any of the power system textbook. The software is also able to calculate the short circuit current at any buses in any of the big systems. That means any number of buses. It is also capable to simulate the three-phase fault, single line to ground fault, line to line fault, and double line to ground fault. The major highlight of this software is that it gives the sequence impedance diagram depicted the sequence voltage and current with respect to the fault bus. That means for each type of fault, the impedance diagram is different and the same is given by the software. Result includes the voltage at all the buses and current through all the branches in the given system during fault. The effect of transformer and generator winding connection in the short circuit study is also incorporated in the algorithm. Therefore, the voltage rise problems and other effect in an ungrounded system during fault also come in picture in this short circuit study. In this video, I simulated a problem, a short circuit problem from the book referred here, that Power System Analysis by Adi Sadat. Here the one line diagram of a simple power system is shown in the next slide, and the neutral of each generator is grounded to a current limiting reactor of 0.25 by 3 per unit on a 100 MVA base. The system consists of two generators G1 and G2, and we want to determine the fault current for the following fault, that is balanced three-phase fault is there, SLG fault is there, line to line fault is there, and the double line to ground fault is there. In all the cases, the fault is simulated at the bus 3 and the fault impedance is J.1 per unit. The detailed description of the impedance are shown in the table. The two generators are represented by G1 and G2. Two transformers are T1 and T2. One of the transformers primary is charged with neutral solid grounded, and the secondary is also charged with neutral solid grounded. G2, the primary is delta and the secondary is charged with neutral grounded. The positive, negative and zero sequence are shown in the figure. Here, if you consider to enter the data in the software, so the software has the provision to enter the details of line, generator and transformer. Therefore, here we add bus 4 and the bus 5 in between G1 and T1 and G2 and T2. Give numbers to each bus in the system starting from 1 to n. Don't leave any numbers between 1 and n. In this case, n is equal to 5. Therefore, we have 1, 2, 3, 4 and 5 in this diagram. Next is to enter the data in the software and perform the short circuit study by creating different types of fault at bus 3 through a fault impedance of J.1 per unit. Here, first click on the YBus new application file in the zip folder. Then click on the short circuit study. Here we enter both the branch data, excluding the transformer details and the generator data. Click enter branch data add a row by click on the add row button. We have 3 branches here, so add 3 row here. The from bus, to bus, positive resistance, positive reactance, positive shunt admittance similarly, and the zero sequence of the shunt admittance. Similarly, the other 2 lines data are also to be added as per the given system. And don't leave any blank row in the data entry table. If you add, click on that row and clicking on the delete selected row button to delete that row. Now we want to enter the generated data by clicking enter generated data. In this problem, 2 generators are present, G1 and G2, so 2 rows are to be added. And the generators are connected at the 4th and the 5th bus. The positive sequence reactance is 0.15 and the negative sequence reactance is also 0.15. Similarly, the zero sequence reactance is also 0.15. So we have to copy this data and paste it here, because both the line and bus number, the second generator is connected to the 5th bus. So now we enter all the impedance data. Here both the generators are neutral grounded. So select star with neutral from the winding from this combo box. At this moment, make sure to enter the generator grounding data by click on the enter generator grounding data button. That is, you can show on the left side. In this set problem, 2 generator G1 and G2 is grounded through a reactance of 0.25 by 3 per unit or 0.08333 per unit. Those value we entered here, 0.08333, 0.08333. Now enter the next page button. This page is dedicated to enter the transformer data. If there is no transformer in your problem, leave this page and go to the next page by click on the next page button in this page. Here we have 2 transformers, T1 and T2. Therefore, we have to add that data here. Add 2 transformer, add 2 rows, and we had that transformer here. The primary is 4, secondary is 1, and positive resistance is 0. Positive reactance is 0.10, 0 reactance is 0.10, and it is connected to 5. Secondary is connected to the second bus, and these 4 data are similar to the T1 transformer. Now select the winding type of the transformer T1 and T2. Don't forget to enter here the primary is star with neutral, secondary star with neutral, and the primary winding is star with neutral T2, and the secondary winding of the T2 transformer is, I think it is delta, and this is the star one. Yeah, correct. Here also don't forget to enter the transformer winding grounding data by click on the enter transformer grounding data button. Here the primary and the secondary winding of T1 are solely grounded. So here Rg is equal to 0 and Xg is equal to 0. That is the default, so no need to edit the value. For the case of T2, the primary is solely grounded and the secondary is delta winding, and the value is automatically appear as INF or infinity. So here also no need to edit the data. Click on the next page. Tick the checkbox here to enter the fault details. When you click on the combo box, all the buses in the systems are appear, and select the bus where fault is to be created. Here in this case the third bus we want to apply the fault. Here the fault bus is 3. Also the fault impedance is 0.1 reactance. The fault bus diagram and the sequence impedance diagram of the system with respect to the fault bus 3 is appear by clicking on the 3-phase fault sequence diagram button. The circuit consists of only positive sequence impedance, and the value of the positive sequence current IFPOS and ZF are also shown in the diagram. More details are highlighted by clicking on this button. Here for a 3-phase fault, 0 and the negative sequence current as well as voltage are 0. The fault current is 3.125 angle minus 19 is same for all the 3 phases. To know the result of SLG fault, before that also we want to know the voltage at all the buses during fault and also the current through all the branches during fault, even though from the generator to the corresponding bus is also shown here by clicking on this button, phase A voltage at buses and current through branches in per unit during fault button. So to know more about the result of SLG fault, click on the next page. By clicking on the single phase fault sequence diagram, the diagram shows the positive, negative and the zero sequence parameter with respect to the fault bus, that is the third bus. Here the 3 impedances are connected in series, so the 3 sequence currents are equal. The fault resistance becomes 3 ZF in this diagram. Here the fault current is 2.7253 angle minus 90 degree. By clicking on the next page, line-to-line fault details are to be appeared. In a line-to-line fault sequence diagram, the positive, negative and the fault impedance ZF, not 3 ZF are connected in series. Here the ground is not come into picture, therefore zero sequence impedance are absent here. Also, the positive sequence current and the negative sequence current are in opposite direction. With this, the algorithm calculated the fault voltage and current and shown in the bottom table. Click next page. For double line to ground fault, the 3 sequence impedances are taken part because of the presence of ground. Here the series combination of 1 angle 0 and positive sequence impedance is parallel with the negative sequence impedance and also parallel with the series combination of the 0 sequence impedance and 3 ZF, because 3 ZF is come because of the presence of ground. Here also the detailed result are highlighted in the bottom of the table. The fault current through the fault impedance is found to be IB plus IC is also shown in the figure, 1.9461 angle 90 degree. The detailed report of the short circuit analysis is generated by clicking on the generator report button. The report can be viewed in the parent folder. Okay. You can see the report by opening this file, short circuit file, the detailed reports of the input details as well as the output details. Output details consist of all the 3 fault details: 3-phase fault, single line to ground fault, line to line fault and the fault current details. Thank you for watching.